ice cream and everything. Okay. Now, basically, here's yet another myth. People think that you can't exploit a Unicode buffer, so that once it's been copied into a Unicode buffer, that interleaving of data and zeros that typically happens is going to mean that it's now not exploitable. Well, you'd be wrong in that case, actually. Chris Anley was the first one to actually publish any information on this. It turns out that on the x86, it very conveniently has variable length instructions. And so what we can do is we can use this to interleave the opcodes and the bytes, etc., so that we can actually cause a Unicode, we can jump back into a Unicode buffer and actually have it be useful. Basically, it's called Venetian method, as in like Venetian blind. So you've got a spot that's open and a spot that's not, and so on. And it's kind of an interesting technique. It requires a somewhat larger buffer than normal. I think about the smallest shellcode that's been put together is around 512 bytes along those lines, or 512 characters. So yeah, it takes a little bit larger overrun than normal to actually exploit it. But I'm sure that somebody really very clever will figure out how to reduce that at some point. So don't ever get the mistaken notion that, oh, well, it's only a little buffer overrun. We'll just leave it in there. That's almost always a very bad idea. Okay. Number one thing, I can't say this often enough, Michael and I could probably say it in a chorus, is don't trust user input. Also, get rid of unsafe functions. Okay, a really bad developer can figure out a way to screw up anything, even using totally safe function calls. If you pass the wrong length to strut and copy, away it goes, okay, etc. But given that, and a really superlative developer will never make any errors, even given unsafe functions in the worst of conditions, right? Okay, for the rest of us, the other 99% of the world, are somewhere in the middle. And the better the tools we've got, the better the results will be. And one of the things that will give you better tools are the safe function calls. So we can use the strut safe functions, which get around a lot of the inherent problems with the old strut copy, strut cat, etc. So use these. Pay attention to your Unicode and ANSI size mismatches. Anywhere you're transferring data between the two, be careful. And lastly, you can use managed code. Now, I'd like to spend a little bit of time talking about the /GS flag. And it was, unfortunately, the subject of a little bit of controversy about a year ago. And it's not because it didn't work, but it won't save you from everything. That's, nothing will save you from everything. I mean, the analogy that I like to use is I've got a really pretty fast car and I like to drive fast, and it's got great brakes and it's got seat belts and it's got airbags. And so if I screw up a little bit, all of those things will save me. I can hit the brakes really hard, the ABS will stop very, very quickly, and off I go. But if I go skidding on the ice and plummet off a 2,000-foot cliff, those seat belts aren't going to save me. But I do use the seat belts religiously. I don't go out of my driveway without them because I just don't know. So it's something that is a good practice, but it does not mean, by any stretch of the imagination, that you can just continue to write crappy code and the /GS flag is magically going to save you from all your mistakes, because it won't. It will magically save you from some of your mistakes. And so if you've done everything else right, you've code reviewed, you've tested, you've written as solid code as you can, and then somehow or another, something has slipped through all of those things, /GS might just stop it from being anything dangerous.
It would have prevented slammer.
It would have prevented slammer. You know, buggy code is still buggy. It doesn't help you with heap overruns. Doesn't help multi-stage attacks. Doesn't help you if, say, a virtual function pointer table is overrun. But then again, like I said, those seat belts aren't going to save me all the time either. But having lived through a pretty nasty car crash without seat belts, I'm not going to do that again. So the biggest thing is to write solid code. I mean, there's not really that's particularly amazing about writing secure code for the most part. It's just writing robust, solid code. If you write code that stands up and behaves correctly regardless of inputs, then you're probably not going to have terribly many security problems as a result of code quality. Okay? So review your code. Go back through it and look at it. One useful technique that I've seen is I look at the diffs of what I check in. So I'll check it in, I'll look at the diffs, so that brings very clearly what did I change. And so it allows me to focus on that. And then get somebody else to review it, a fresh set of eyes. Hey, you know, would you take a look at this? I changed this and this and this, and here's what I was thinking about, and this is what I did. And does that, you know, does that look right? That'll catch a lot more stuff, all right? Now, if it's really important, get somebody who really knows what they're doing to go through it and review it, hire them, pay them lots of money, and then test some more. It turns out that there's only so much that you're ever going to catch through code review. There are certain classes of bugs that require all sorts of state information, etc., that only happen under really weird circumstances, and you can find these through testing. And you'll be more effective at finding these through testing. I was talking with somebody in one of the internal product groups, and they said that they had created a fuzzer for their protocol that was intelligent about their protocol and would just abuse the hell out of their protocol. And what they said is they found roughly a third of their bugs through threat modeling, another third through code review, and the final third came out of really solid, extensive testing. And that particular component has a very, very low rate of security fixes. So, so these guys are doing something right, and that's where I try and look at. So, zip right through this since we're running behind.
Just keep going.
Okay. Let's talk about sockets. I like to write sockets code, networking kind of stuff. It's fun, and it helps me go, you know, take over things and do useful things on the network. And so I tend to like sockets. It's one of my favorite topics. Now, here's an interesting thing that some of the guys that were part of the loft figured out and brought to our attention back in, I think about 1997, 98, is that a socket that's bound to inat or any can be hijacked by one bound specifically to a specific IP. Now, who understands what I just said? Almost nobody. Okay. So what that means is when I go to bind a socket for listening on a server, I can specify what interfaces I want it to listen on. If I want it to listen on all the interfaces on the machine, I specify 0 for the IP address, and it just magically listens on all the interfaces on the machine. And if people pop up and down wireless and take cards in and out and all that, I'm still listening on all the things. So it's very, very convenient. Okay. Now, if somebody comes and rebinds to the same port but specifies a specific IP, Now they're more specific than I am, and they get preference. Okay? So what they can then do is they can then intercept my traffic, modify it, play man-in-the-middle attacks, sniff it, etc., and then pass it along to the real server. So the real server really doesn't understand the difference. He just sees a lot of connections from 127.0.1, all right? So what we did was created a socket option that got rid of this problem. It's called SO exclusive adder. And so one of the best things to do is to go ahead and set this option, and now you're not susceptible to hijacking. The operating system is going to say, all right, this is the only person I'm going to give this particular port to. Everybody else can't have it, whether they're more specific or not. And it helps a lot. It also, one thing that you do have to pay attention to is you have to shut down these sockets cleanly, because otherwise you can get into sometimes a condition where if you bounce the server, drop it, and try and come back up, then the stack still has some things open and you'll fail coming back up. But that won't occur if you shut down the socket cleanly. I go into a lot of detail in the book on this, so I'm going to try and flip over it here. Now in Windows Server 2003, we've actually put access control lists on the sockets. And so it mitigates this threat without setting SO exclusive adder used. Now I suspect it's going to be a good long while before most people are writing code specifically for Windows 2003 and later. Okay. Now, when you're writing a network-aware application, one of the worst things you can do is fail to give the user choices about where it's going to listen. If I'm trying to configure a system for use on the internet, then I want that front end to expose as little as possible, and then the back end exposes a richer interface so I can administer it, et cetera, et cetera. And so I'd like to just turn off things that listen on the internet. I don't want to rely on the firewall or something else in front of me to block things. I want that just to be off. I want to take the position, defense in depth. If that firewall in front of me failed, I still want to not to fall over. So the minimum level would be to allow the user to specify which interfaces we're going to listen on, which network cards. Now this can get a little bit tricky, because if you specify a network card and then you go ahead one day and change it, now you've got an application that's not listening on anything at all, and it can take you a little bit to figure that out. Now even better is specify which IP addresses it'll listen on, and that's a second stage. And then the best is to allow the user to restrict the client-side IPs as well. So I can say, all right, this service is only going to really talk to people on this set of IPs, and now I've got a richer set of configurability. Now, what's also convenient in some cases is to allow the client and the server to customize the port used. We see this on web servers all the time. You see HTTP something 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 colon port number, and away we go. IPv6, which is going to be really cool when we can actually use it, allows the concept of a local network, a site-level network, and a global network, and you can also listen on local site or global addresses. And so that's some really cool flexibility. Now, some people think that firewalls are going away. They're just terribly archaic, and nobody's going to use them in some sort of bright and shiny future that I really don't see coming. I don't think they're going away. I think we're going to see more of them. I don't think you should depend on it as your sole line of defense. That's ridiculous. But they're not going away. There's too much stuff out there that's trying to get you not to have a single device that's blocking a lot of the junk if for anything else, it's just to preserve your own bandwidth. Why let the attackers use huge amounts of your internal bandwidth when you can just block it at the gates? Another thing that you'll see, I think, increasingly is a lot more people using host-level firewalling. Yesterday, Steve Riley and one of the guys that works for me, Tim Ballifer, were talking about what we used for OpenHack, and we used IPsec configurations to implement some firewalling, and that pushed things right down to the host level. And there's some neat stuff you can do with that because you can enforce it at group policy level, et cetera. But what the net bottom line is these firewalls aren't going away. And so you ought to write an app that's friendly to firewalls. Okay, an app that's like not friendly to firewalls is, say, FTP. Make a connection out to 21, say, yeah, give me this data. He says, fine, I'll connect back to you on port, whatever port you just specified. Well, now I have to open up my firewall rules to allow connections in.'s a prescription for disaster. All right, so that's an example of how not to write a firewall-friendly application. And so if you're writing an application, follow a few rules to make it easier on yourself. Use one connection to do the job. Don't make connections in both directions. TCP/IP is quite capable of transmitting data in both directions. I don't need one socket for each direction. So, use it. Use it for what it's worth. Terminal Services does it right. Everything runs over one port, one connection, and it's very easy for me to set up a firewall rule that allows Terminal Services to this one machine and just have it all work. Don't use UDP if you can possibly help it. It's very, very spoofable. The connection-based protocols are a lot easier to manage in the long run because you've got a directionality to it. I can make a firewall rule that says I'll allow connections in but not out, or out but not in, whereas with UDP, I don't know whether it's in or out, it's just going somewhere. So yet another area to look at is that host-based trust is inherently very, very weak. Port-based trust is even worse. Older Unix protocols had the R services, RSH, RLogon, et cetera, and they basically assumed that if you're coming from a machine that I knew about and we're coming from a low port, then you must be root on that machine, and so I'm going to trust you and I'm just going to run whatever you ask me to. Well, yeah, those things were built in a far friendlier time and era than we have now. They're just simply not appropriate. So don't base trust on a host name or an IP address or worse yet, a port number. Don't trust DNS names. You don't know. Somebody might have corrupted the DNS records. There's a whole bunch of different ways to screw up somebody's DNS. They may have forged a bad response to your query. You said, all right, where's www.foo.com? And they said, oh, I know, it's over here, bam. And now your resolver's corrupted, and now you're going to the wrong host, and away we go. If you need to know who a client or a server is, require a shared secret. Use some cryptography. Use some certificates. Make sure you know who you're talking to, all right, because you can't rely on DNS names. It's just not something you can really trust. Denial of service is yet another pet peeve of mine. Sometimes there have been times in the past where I've gone to talk to people and they said, well, we've considered all the security stuff. I said, well, what happens if I open 10 million connections? Well, that's denial of service. We haven't worried about that yet. Well, what good is your app if it's not running? None at all. So you've got to consider this. Got to plan for denial of service in your threat modeling. There's several types of denial of service. There's crashes. It's almost always a code quality problem that causes crashes, trusting user input, et cetera. There's CPU starvation attacks. These are a little bit harder to figure out. and it's typically due to inefficient code. There's some function that behaves really well when you give it 10 characters worth, that behaves really poorly when you give it 512 characters worth, or some variation thereof. You can overcome this by inspection. You can overcome it through testing and profiling. Figure out what functions are really eating the CPU. Do some function level profiling while feeding in abusive input, and that'll really show them up. Make sure you test for pathological inputs. And for example, a few years ago, if I did a list ../*./* go on for a while against a particular implementation of FTP server, the CPU would go to 100%. It would stay there for several hours. Okay, that's no good. That's the type of thing that we want to avoid. Memory starvation attacks are another class of denial of service to be aware of. A couple of main rules to remember here. Don't pre-allocate large structures until you're sure you have a valid client. We had a problem with this in terminal services a couple of years back, where you just make a connection to port 3389 and bam, it allocates a meg of data. Just getting ready. Well, what happens if somebody's port scanning you? That's no good. So we fixed that one. You also want to place bounds on the amount of input that you'll accept from users. I mean, say you decide you're going to get rid of buffer overflows, you're going to dynamically allocate everything. So then somebody feeds you, 2 gigs worth of string. Now you're out of memory. That's no good either. Okay. Resource starvation is actually a much, much more difficult problem to manage, because we get into a situation where, okay, for every new connection, I'm going to spawn off a new thread or process to service that connection, and away we go. So now somebody comes along and establishes 4 million connections to my box, and then it falls over. Okay, fine. Well, that's no good. So what do we do? All right, well, let's put a cap on the number of connections. All right, 4,096 ought to be enough for anybody. So now one guy comes along and allocates all 4096, and now nobody else can get it. Well, that's no good either. And then you say, okay, well, I'll make it per user, per IP address. Each IP address can only have, I don't know, 124 or something. And then it turns out that your most popular client is somebody's proxy server, and now your most popular client is getting wedged off all the time. And so now that's not a very good approach either. One of the most interesting approaches is to change behavior, whether or not you're under attack or not. If you start entering so what you want to do is set up logic to hit a phase where you know that you're under attack, you're seeing resource starvation issues, and so now we're going to change behavior to start shucking off people that aren't progressing normally, look for abusive situations, start closing their connections, and defend ourselves. There's a lot of logic built into particularly the SMB implementation for that right now, and it's very, very effective at shucking off attacks. There's ways, for example, to really kill the CPU on any machine that exposes SSL. This was presented at Usenix Security Symposium 2 years ago, and they also presented an interesting approach, which is going to take some standard changes to roll out, but it's a useful thing to think about, which is to make it as CPU intensive on your attacker as it is for you to respond. What you want to look out for is a situation where it's very cheap for somebody else to get you to do a lot of work. So these can be very, very complex and difficult to work around and require some pretty extensive design modifications. So, as a software manager, the last thing in the world I want to see is big changes late in the process. What I'd really rather do is think about these things very early on and get them fixed early. Now, impersonation is a fun thing to look at in any kind of operating system, and so what's wrong with this code? Anybody see? A couple people. Okay, what we're going to try and do here is we're going to impersonate the logged on user, and then if the user is an admin, then we'll go do horrible stuff, and then we'll revert to self. Well, what if the impersonation failed? It could have failed. And if it did, then you're going to continue running under your elevated account, and you're going to perform actions on somebody else's behalf, and they've just escalated privilege, and you've had it. Okay. You also want to be aware of clients that can impersonate you if you're a privileged process. You want to really look out for those types of things. An interesting wrinkle on this is COM and RPC callbacks. So I'm going to say to this COM object, say, hey, I'm going to register this sync. Let me know when you're done. Then he pops back to me when he's done. Now that server has just become my client. If that server doesn't take care to regulate the level at which he can be impersonated, then I can impersonate the server and escalate privilege that way. So that's something else to be aware of. Next is don't impersonate and then just execute whatever comes along. If your model is well, somebody's going to hand me a DLL and then I'm going to just run it. If they call revert to self, you've had it. So that's something to look out for. We made a change for this in Windows Server 2003, where we decided that impersonation should be a privilege and that not everybody should have it. It reduces the potential for local escalation of privilege attacks. And so right now it's admins and service and accounts only that can do this by default. So if you've got an app that requires impersonation and it's having problems on 2003, this could be why. But if you need to, you can add that, whatever user you need into the privilege, and that'll fix the problem right away. So always check your returns, look for impersonation functions, and always allow only identify on what's going on. So here's what to do. Code review and testing, I can't stress this highly enough. Think about integer overflows. It's not something that's really commonly talked about a whole lot. There's not a lot of awareness in this area, but the attackers are certainly raising awareness in this area for other attackers. And so people that are trying to, not be attacked need to really be aware of it too. Countermeasures for denial of service are very often quite complex, and so you better plan that into your development schedule really early and check your returns. I think I get turned over to Michael now.
Thank you very much. I just want to tell you a little story about the impersonation work that we did, the impersonation privilege that we added to Windows Server. So I was the guy who pushed it through to get it into the product. And basically what we did originally, the original plan was we weren't going to grant this to everybody. Originally it was just going to be granted to admins and service accounts, which is network service, local service, and local system. And the RPC guys basically got the whole of Windows. Everyone who ships anything in Windows to run all their regression tests, absolutely everything. It took about 2 weeks. And the RPC guys came back really moaning because basically 20% of their regression tests worked. The other 80% just failed because of some of the funky stuff they do with impersonation. So we decided at that point, by the way, this is November last year, where this was all happening. This is like release candidate 2 of Windows Server. And so we decided that we would grant the privilege to everyone and then allow people to take it out if they didn't need it. So we presented this proposal to Jim Olchin, who is the big head honcho of Windows, who basically looked me square in the eye and said, go back, think about it some more, we're not granting this to everyone. No way. And so I went back, thought about it some more, and basically we looked at the bugs that were being found in RPC and DCOM, found a way around it, and they fixed a whole bunch of the issues. They fixed their bugs so we could maintain the privilege. And in the end, 99.7% of their regression tests passed, and the other 0.3 that failed, they actually admitted were just not real-world scenarios anyway, and they were just torture tests, and they were happy at that point. So it's just an idea of like how some of the culture is changing. The fact that Olchin stared me down and just said, we don't pay you the money you do to wimp out on things. Go back and think about it some more. I want to ship a secure product. The other thing I want to also point out is that in the framework, just talking about integer overflows, if you're writing in VB.NET, integer overflows will automatically cause an exception. And in C#, they don't. You need to put the word checked around the operation, and if there is an integer overflow, it will throw an exception. So there is actually support in the framework for helping mitigate integer overflow attacks. Right, so I want to move into sort of a different area. Because you probably worked out by now that David and I, we we have similar goals in life, but we do things in a different way, and we work on different technologies. And one of the areas that I tend to spend a lot of my time is in the area of crypto work. And I've seen it all, and a lot of this stuff, encryption, which is where people think that exclusive OR is, the savior, and I'll just like use exclusive OR in a funky way with some numbers that no one's ever going to work out, and no one will ever break my encryption scheme. Well, anyone's kid sister can break most of these things. So, don't roll your own crypto functions thinking that no one will ever work it out. And in fact, you know what? Encryption is easy. The hard part of cryptography is not the encryption. It's the key management. That's the hard part, not the encryption. So just call crypto API, or if you're using C and C++ on Win32, or system.security.cryptography, which if you're using managed code. If you're using, say, VB or ASP or some COM client, some high-level scripting client, then use CAPI-COM. And the other one is, don't store secrets in code or in configuration files because they will get found out. On that very subject, storing secrets in software is impossible. Your threat model should reflect the fact that the secret data can be compromised if certain conditions exist. But you can raise the bar substantially. At least try to raise the bar. Embedding secrets in code don't stay secret for very long. So obviously don't go doing that. I actually heard one guy, luckily not someone who was on a news group. Luckily the guy doesn't work for Microsoft. Otherwise we'd be having a little chat with the guy. But he was saying that because, for those of you not aware, but Visual Studio 2003, which is about to be released, we've included a community edition, I think that's the correct word, of an obfuscation technology for managed code. And so this guy in the news group said, well, does that mean I can start embedding passwords in my code because no one will work it out? It's like, no. Don't embed secrets in code, period. Obfuscation technologies or otherwise, just don't go doing it. The recommended way of doing it today, obviously this depends on the threats, is to use the data protection API. That does require Windows 2000 later. There are no plans to backprop this to NT4 or to any version of the OS prior to that, because there's actually a lot of infrastructure required to support DP API. It's much more preferable to LSA secrets, if any of you are familiar with LSA secrets, for a number of reasons. In the subject that David talked about least privilege, there's 4 reasons most of the time why people have to run as system or as admin. One is an ACL problem. The other one is you're opening some resource for full control or all access, and the ACL says you need to be an admin to do that. Another one is a privilege that's required, and another one is if you're storing LSA secrets. because to call into LSA secrets requires you be an admin. Actually, it's kind of funny. The LSA secrets APIs to actually store and retrieve the data don't require you to be an admin. But to get a policy handle requires you to be an admin. And we'll have to guess what the first argument is on the LSA secrets APIs, the policy handle. So you actually need to be an admin to store an LSA secret. So there's actually two services in Windows that used to run as system that now run as network or local service because they no longer store their secret data in LSA secrets. Rather, they store it using the data protection API. The other reason for using DP API over LSA secrets is you got to like write this much code just to get a handle, essentially, to the LSA and do sort of the prep work, and then finally do some funky stuff and you stored the data. And then you probably got an AV somewhere while you've been doing that. Whereas in the data protection API, there are just two functions, crypt protect and crypt unprotect data. They're dead easy. Also, DP API does not persist the data for you. You get given a blob back, and then you can persist that data. The nice thing about that is that you can store it in a registry, or you can store it in a file share. You can store it in an XML configuration file, whatever. And that means that you can back up your application and back up the secret data. Whereas if you're storing data using LSA secrets, you've got to do a system backup, which you may not want to do. You may want to sort of back up the application. The other nice thing is DP API provides an integrity check as well, to actually know whether the data has been changed or not. And there are some options in DP API, but the general rule of thumb is that the account that encrypts the data is the account that can decrypt the data, because it's actually key material that's tied to your password and is held in your profile information. So storing secrets in memory. So there's a new API. So basically the way you store secrets in data, by the way, the main threat here is the crash dump. If there's some secret data in memory and the application crashes and a crash dump is written out, then potentially the data could be written out to the crash dump file as well, which means one of two situations can possibly exist. What happens if the crash dump file is sent somewhere, or what happens if someone can read that crash dump file? You may now have access to the secret data. There's also a small window of opportunity that data could be paged out to the page file. I'm not too worried about the threat of someone hooking a debugger up to a running process, because I'm just going to wait until the data is unencrypted. I mean, I don't think that's a real threat. But the crash dump, I think, is actually a very valid threat. And so basically the way your application should deal with secret data in memory is you acquire the data, immediately encrypt it if you want the data to be relatively long-lived, decrypt it, use it, redo as necessary. And then finally, when you're done, you just scrub the data. So you keep the window of opportunity when the secret data is exposed in the wild as small as possible, which means that if there is a crash and the application crash dumps, or crash dump file is created, the window of opportunity of it being in plain text is greatly reduced. Now, obviously, you're not going to encrypt all this stuff in memory. There's some stuff you just don't care about. But some stuff should absolutely be encrypted in memory, like keys, personally identifiable information. I mean, privacy is a big issue. It's one of the four cornerstones of trustworthy computing, is the whole notion of privacy. If you're dealing with health information or anything that's personally identifiable, you may seriously have to consider encrypting it in memory in case it's leaked out. There's a function that we've added to Windows Server 2003 called crypt protect and crypt unprotect memory. And you can tie it to the running process, you can tie it to the machine, and you can also share it across processes as well. But the default is to lock it just for that application. So just that process can encrypt and decrypt the data. There was originally no plans to backprop this to prior versions of the OS. However, crypt protect and crypt unprotect memory are basically just a wrapper over an internal function called RTL encrypt and RTL decrypt memory. They are now documented in the platform SDK. And in fact, on this slide, this is not in there, but when you get the soft copy of these slides, that C++ file is actually some wrapper code to call RTL encrypt and RTL decrypt memory. The reason why I've done that is because RTL encrypt memory and RTL decrypt memory are not exported from the DLL. So these are a bit of funky stuff to call them. So they're now documented in the platform SDK. So now you've got this support on Windows 2000 and on Windows XP. You'll notice that bullet point 5 there is scrub the data when you're finished with it. Well, it turns out that calling memset may not work to scrub the data. So imagine the following function. Foo It's got a stack-based buffer. It doesn't have to be a stack-based buffer, but just for argument's sake, let's just say it's a stack-based buffer. Let's say it's called password. You get the password from the user, do funky stuff with password, memset. So what's wrong with that code? Well, the actual question is, the actual answer is there's nothing wrong with the code. The code, the C code, is absolutely fine, so long as you don't compile it. If you compile it, now you've got a problem. Because there's a very simple peephole optimization that just about every C and C++ compiler does, where they know the semantics of memset, and it realizes that you're writing to this buffer, and then the function finishes, and nothing is reading from the buffer. It's called dead store removal. And so it realizes that no one's reading from the buffer again, and it's the end of the function, so why even bother doing the memset? And so the optimizer, even at some of the lowest levels of optimization, it's a peephole optimization, removes it from the code. So the code is fine, but the generated code doesn't have the call to memset. And believe me, this actually affects a lot of compilers. This is not a Visual C++ bug. It affects a lot of compilers. So we ended up writing a little macro called secure zero memory, which basically just plays volatile pointer tricks to not be optimized out. It's available in winbase.h. You're more than welcome to use it in your own code. But I wouldn't use it for everything. I would just use it for scrubbing secret data because it's dog slow relative to a call to memset. In terms of access control issues, and sort of David's alluded to some of this, but be very careful about what ACLs and permissions you have on certain data. Because sometimes an ACL like everyone read may not be appropriate for some kinds of data, like a key, for example, an encryption key. You may not want everyone to read that data. You may only want admins to read that data. So be very careful about what ACLs you're using to protect certain data. Also, don't depend on inheriting system defaults. In general, the system defaults are actually very good now in Windows XP onwards. And in general, you can create something in the right place and you'll inherit a good default ACL. But don't rely on it because it may not be correct for what you want to do. There's also another type of DACL called a null DACL, which is just plain evil. They are now banned in Windows. Basically, as we probably already know, but all objects in Windows NT, all named objects, can be protected with an ACL. And if you have a null DACL, it means you have no defense. You do not have an ACL on the object. There is no defense for that object. There was one null DACL in Windows XP, and we let it slip through. We fixed it in XPSP1. But what it was, the little balloon that pops up in the bottom that says, hey, you're running low on disk space? Well, that was protected by a mutex, so we didn't have multiple balloons popping up. So the application didn't try to pop multiple balloons up. Well, there was a null DACL on that. And the attack was that you could change the DACL on the object, on the mutex, to say, deny access to the mutex. So no one could ever acquire the mutex, so the balloon would never pop up. To some people, that was actually seen as a feature. And we're like, you know what, there's no security issue here. We're not even going to bother. We'll fix it in Service Pack 1. It's just not an issue. So that was the only known null DACL in Windows XP. You've got to be aware that if you've got a call to set security descriptor DACL, and the second argument is true, and the third argument is null, you've got a bug. You have no protection on that object. Anyone can do anything to the object, anything whatsoever. You have no protection. So ActiveX controls, we've actually now got a rule in place. Thou shalt produce no more ActiveX controls unless you've got a really good reason. And you better have a really, really good reason to come up with a reason for generating a new ActiveX control. All new functionality of that nature should be moving over in Microsoft over to manage code. And part of the reason is a lot of people mark their controls as safe for scripting, which is just literally like saying, yeah, just trust me, I'm safe to be scripted. So let me explain very briefly what that means. So if you look at Excel, Excel does what it does, and it does what it does very, very well. It does number stuff, it does charting stuff, it does pivot table stuff, and it's a well-written app, and it's not designed to be malicious, and so on. However, it exposes an object model. And that object model allows you to do the equivalent of a file save as c:\boot.ini. Save out an XLS file as boot.ini. Why can you do that? Well, everyone's an admin. So you can stomp on the boot.ini file. But what the whole point is that means that Excel is not safe to be scripted. Because script can do anything to the object model, and who knows what it could do. So if you can actually stomp over something, change something, or expose sensitive information, then that's an example of something that is not safe to be scripted. So let me give another couple of examples. There was a bug found in an ActiveX control just before Windows XP shipped, about 3 months before the product shipped. There's an ActiveX control that had one method on it called print. And this ActiveX control was marked as safe for scripting, which means it may not throw a UI when you instantiate it, depending on the security policy in IE. Well, this print method had two arguments. One was a directory, the other one was a printer location. And so what I could do is you come to Mike's bad website, I can instantiate this control. You may not know about it, depending on your security policy. And I can print the contents of your My Documents directory on my printer across the internet. So the first question is, you can't do that. You can't print across the internet. Of course you can. Internet printing protocol built into the product, you bet. And so that's an example of something that's not safe to be scripted. As it turned out, that method wasn't even needed. It was there for debugging that someone accidentally left in. And so it just got pulled all together. A couple of other examples. I was asked to review some 3 ActiveX controls. Actually, about this time last year, they're going to be shipping out a band of any Windows product. There's 3 ActiveX controls. And I was asked, were they safe for scripting? And it was really easy. No, no, no. It was real simple. And the reason was the first one allowed you to manipulate digital images directly on a digital camera. Problem is, that also included deleting images on the digital camera. So you could hook up your digital camera with your 1 gig micro drive after coming back from your vacation in Nepal, which you're never going to go back to ever. You come to Mike's bad website, I instantiate the control and delete all the pictures on your camera. By the way, I can enumerate all the camera connections as well and just walk through them all and delete them all with no knowledge of what the cameras are. Not safe for scripting. Another example was a control that controlled webcams. And once again, I could actually enumerate all the webcams connected to the machine and turn them all off. So those are examples of controls that are just not safe for scripting. So the reason why these are issues is because you can actually repurpose an ActiveX control. You can have an ActiveX control that comes from a specific website or is on the box, but another website can call that ActiveX control. Now you can bind an ActiveX control to a website. In other words, I will only do funky stuff if the request came from my website. There are ways around that, and I'll sort of get onto some of those in a moment. But we've basically outlawed new functionality except in exceptional circumstances as ActiveX controls. In fact, I had a conversation about this time last week with some people in the PKI division, and there's some functionality they want to expose. They're doing pretty sensitive stuff on the client, and they said, should we write this as an ActiveX control? Well, why are you even considering an ActiveX control? And I said, well, we want backward compatibility to Windows 95. It's like, how much do you really want that backward compatibility to Windows 95? And they said, well, not really. It's not a big issue. So how sensitive is the data you're dealing with? And they said, it's extremely sensitive. So are you willing to compromise a future version of the OS where things are going to get better for the sake of just running this stuff on Windows 95? And they said, no. There was a 30-second conversation. The whole thing's going to be written in managed code, not as a C++ ActiveX control. That way, it's less possible. The chance of them making a mistake is greatly reduced. So I'm going to talk about some of the web application issues, and then we'll finally wrap it up. But Dave's already alluded to this, and I'm going to say it again. And you know what? If your neighbor's asleep, nudge him, wake him up. I'm going to tell you one thing. I'm going to tell you one thing only. You can either go back to sleep or leave after that. Quite frankly, this is probably the single most important thing that developers need to understand, and that is that all input is evil until proven otherwise. Because good guys always give you good stuff, and bad guys don't. If you look at the slammer worm, one of the issues there was the fact there was this UDP packet. The first bytes of the UDP packet can be treated like as a verb. And then the rest of the payload is the data that's associated, like the noun that's associated with that verb. Well, it turns out that if that value is number 4, it means give me some information about an instance of SQL Server. And the rest of the data was the registry key to open. And so what happened inside is the SSRP code is they would build up this string because normally the only bit of code that would hand off a packet like that came from the SQL Server team, from a client code, some client code that's written by the same guys that wrote the server. It was always well formed. Attackers don't use SSRP.c, which is where the buffer overrun occurred. They don't use that. They write their own little Perl script, as David so eloquently showed. They bypass the client altogether. And so don't trust the data because you have a client app, because bad guys don't use your client app. They go underneath the radar. And if you look at just about any security issue, not any, I mean, there's information disclosure attacks where you can view sensitive data. They don't really count. But things like buffer overruns. Why do buffer overruns happen? Because you expected this and got this. That's all it is. It's an input trust issue. Why do canonicalization problems happen? I'll explain what they are in a moment. Cross-site scripting issues, SQL injection attacks. They're all because you expected something well-formed and someone gave you something different and you never expected it. So I'm not kidding. You know what? You can get up and leave now if you promise that all your code from now on will never trust one byte that comes into the system. You can leave. I don't give a crap. Just that one little lesson. I truly believe that developers take that one lesson and take it to heart, we'll have solved just about every problem out there. Sure, we'll have a bucket load of other issues, but we'll worry about those later. If we just solve that one issue, we'll have solved so many problems. I'm dead serious. All right, off the soapbox for a minute. So canonicalization problems, never make a decision based on the name of something, because there's often more than one way of correctly naming a file or a resource. And the thing is, if you look for something, you say, well, if I see this, I'm not going to allow it. What happens is an alternate way of naming it, which is still valid. And here's just some examples. I give web examples, but these don't have to be web examples at all. I'll make a request for default.asp dot. So let's say, for example, I got a file that says, some code that says, well, if someone makes a request for default.asp and the name is Michael, I'm not going to allow them access. So what I do is I make a request for default.asp dot. And whatever the app is, passes that request onto create file, and create file says, oh, the OS says, well, the file system says that dot shouldn't be there, strips it off. I now have access to default.asp. The irony of the second one is it only happens on our secure file system, NTFS. So upgrade to FAT. No, I'm only kidding. But what this is, and the example here, this was found a long, long time ago in IIS, but IIS has these, or had, doesn't have it anymore, has a default case, but doesn't have that default case anymore. If you see a request for a file, it said, oh, it's a .asp file, it would route it onto asp.dll. If there's a request for a .htr file, it would forward it onto ism.dll. If it didn't know what it would route it onto the default handler, which was just to pass it onto the file system. What happens is, if you request default.asp : $data, you're actually passing, when it gets into NTFS, NTFS says, oh, you mean the default data stream. Colon, no name, colon is the default data stream. And $data is the $data type. You can actually type data streams. And it would return the source code for the ASP file back to the attacker. The one below it is actually an overlong UTF-8 escape for a backslash. So %C 1%1C is actually a 2-byte representation of a backslash in UTF-8, but it's invalid. The canonical form of any byte representation in UTF-8 is the least number of bytes that can represent that character. And so a backslash is less than 7F, and it can be represented in 1 byte. This is 2 bytes. And what will happen is IIS would see and say, www.foo.com wax script, so it thinks, okay, I'm executing, because the scripts directory is marked as execute stuff, which, by the way, IIS 6 no longer does by default. Then we'll see dot, have no idea what that is. So it thinks it's a subdirectory underneath scripts, but it's not. But it still thinks it's executing because there's no directory there. A bit further on, IIS will then clean it up and say, oh, that's a backslash, but it's not. It's actually an invalid character. It's an overlong escape. and then it would put the backslash in, which was the mistake it made, and then would actually execute it. The problem is you're in the scripts directory, marked as execute, walking out of the scripts directory, then down into, say, winnt system32 tftp.exe or something like that. It would execute it. The reason why the next two are interesting is because of functionality that's exported by URLmon. URLmon exports these things called zones, and the most common consumer of zones is IE by far. And there's 5 zones. There's my computer, internet, intranet, trusted, and untrusted. And what happens is there's a little heuristic that URLmon used to use, which was if it saw no dots in the name, then it must be a net bias name. Net bias can't be routed, therefore it must be behind the firewall, therefore it must be in the intranet zone. Well, the first one, which is all those numbers, is actually a dotless decimal IP address, where you take the first octet, multiply by 2 to the 24th, second octet 2 to the 16th, third octet 2 to the 8th, throw in the fourth octet for good measure, add them all up, that's your dotless decimal IP address. Has no dots in its name. But that could be the IP address for Mike's bad website on the internet. So what it does, it puts you in the intranet zone, which will probably have a less strict security policy than the internet zone, and stuff may work in the intranet zone even though this website is on the internet. And the last one is just stupid. There's no dots in that name, right? Yeah, right. %2e is just an escape dot. I've actually seen someone say, luckily, once again, not inside Microsoft, otherwise we would have had a little chat with that person, where they said, what we'll do is when we get these requests, we'll just unescape them, and that's fine. And then we'll see, these www.badcode.com. Well, it turns out you can escape escapes. So you could have %2f 2e, and %2f is actually an escape %. And so if you do one level of unescape, you still got a %2e left for dot. The sad part is you can escape escapes. So this guy actually proposed, once again in the news group, that what he would do is write some code that span in a loop, unescaping until there's no escape characters left. So what's an attacker going to do? Send a bajillion requests that are a few thousand bytes long, where it's an n-level nested bunch of escapes. And now the app just spends all its time spinning in a loop unescaping. It's denial of service. URL scan, which is a nice API filter that sits in front of IIS, will do one level, by default will do one level of unescaping, and if it sees escape characters left, I think it just does a 404. Doesn't even bother going any further. So the other reason, so the whole point here is not making decisions based on the name of something, because you will get it wrong. And you know what? When you think you know all the right things, along comes something else to prove you're wrong. So how many of you are even aware, that don't work for Microsoft, how many of you are aware of the Turkish I problem? All right, you're going to learn something then. So it turns out that Turkish has 4-letter I's. How many of you knew that one? I actually knew it beforehand because it's actually in the Chicago Book of Style. Not as a security issue. They don't have security vulnerabilities in there. But it turns out they actually had mentioned in the Chicago Book of Style that there are 4-letter I's in Turkish. So if you take a lowercase I with a dot and uppercase it in the Turkish locale, you'll get the one that's in from, just one in from the right, you'll get an uppercase I with a dot above it. And if you take a normal sort of Latin uppercase I without the dot and lowercase it, you'll get the second I, which is like a lowercase I but with no dot. And so in the Turkish locale, uppercase F-I-L-E does not equal F, funny-looking I, L-E. They're totally different strings. So let's look at this code. Oh, by the way, that's what it looks like, an I with a little dot above it, big I with a dot above it. So this is actually some code that was found in the framework, the .NET framework, quite a while before we shipped. And someone started thinking about different locales and canonicalization issues. And there's some code that looks a little bit like this, which is basically someone makes we're never going to allow someone to do a file request, file : whack whack. So if we see someone making a file request, we're going to reject it. There's actually a little lesson to be learned from that, which I'll come on to in a minute. So what they do is you uppercase it, and if you see the word file, then now you can't do it. Well, in the Turkish locale, if someone makes a request for lowercase f, lowercase I with a dot above it, lowercase l, lowercase e, and uppercase it, you end up with this over here. That is not the same as file without the dot above it. And so the string compare doesn't compute, so now I have access to get stuff using the original URL, which is lowercase f, lowercase I, lowercase l, lowercase e. All because you're in the Turkish locale. Well, there's actually another little meta rule here, which is never go looking for bad things, because it assumes you know all the bad things. So when we spoke to these guys, I said, well, what do you really mean by don't allow file? Well, they said, well, really what we mean is only allow HTTP. Well, why don't you do that instead? Because if you look for just HTTP and nothing else, if you don't see something, let's say in the Albanian locale, it turns out there's a funky H. Well, if you don't see HTTP after doing an uppercase of HTTP, you're going to get a problem in the Albanian locale, which, you know what, is going to annoy a couple of people in Albania. But it's a lot better to annoy a couple of people in Albania than have the whole of Turkey compromised, depending on your politics. So the lesson here is when you're looking for things, don't go looking for bad things. Ooh, if I see a request and it's got some bad thing, I'm going to reject the request. Because that assumes you know all the bad things from now until eternity. And you know what? No one is that clever. No one even thought about the Turkish eye problem. And all of a sudden it becomes a real vulnerability. Okay, it only affects the Turkish, but it becomes a real problem. And how many, do we know if there's any other ones like this? There probably are. That don't rely on locales, they may rely on other things. We don't know. So you should only ever look for what you expect. If you don't see what you expect, reject the request. The worst you're going to do is annoy a couple of people. It's certainly a lot better to have someone phoning you up saying, I'm annoyed, versus a million people phoning you up saying, you know, I've been hacked. It's a lot better to have the former. I'm not going to spend much time on cross-site scripting issues. I assume you all basically know what they are. But the core lesson here is not the fact that the script runs in a browser, and it's not the fact that the server sends some data back to the client when it shouldn't do, that's interpreted as data, but it's actually code. The real issue is trusting input again. So, you know, here's some classic code, you know, response.write, request.query string, or, you know, whatever. Some data that comes from the client is just echoed back into the client, into some other client's browser. So this is an example of a little web page that you can hardly read. And it just takes someone's name as in the query string and echoes it back. And the assumption is it's always somebody's valid name. Well, what happens, and the rest of the body's always escaped, so you can't read it. But it's like name equals, and it's some JavaScript and HTML. So the web page echoes that back because it thinks it's just someone's name, but it's not. It's JavaScript and HTML, and executes it. And in this case, it can actually steal someone's cookie. You may think, well, whoop-de-doo, who cares? You'd be amazed how many banks store the user's password in a cookie. So if I can steal that cookie, I now have your password. And that could be really nasty. You can start moving funds around. The next one is SQL injection attacks. And I assume you all kind of know SQL injection attacks, but the issue here is trusting input again. I'll explain why in a minute. I wrote this in C#, and the reason why I wrote this in C# is I originally wrote this in C++. I actually don't know VB very well. So I originally wrote this in C++, and I was calling to OLEDB, and someone told me, you know what, as soon as the managed code stuff ships and C# ships and VB.NET ships, you security guy is going to be out of business. I'm like, great, why? He said, well, all the security problems go away, which just made me write it in C# to make a point, which is the problems don't go away. You still got to think about this stuff. So there's a whole bucket load of vulnerabilities in here. I'll explain some of them very quickly. First one is we're connecting his SA back to SQL Server, sysadmin account. I'll explain why that's a bad thing shortly. Next, we're embedding a really hard to guess password in the code. You know, don't embed secrets in code. Next, we're using string concatenation to build up a SQL statement, and you'll see why that's bad in a moment. And last, but by no means least, if there is an error, this code tells you exactly why this whole thing failed, which gives the attacker a lot of information. There's actually a fifth bug in here, and that is that if this connection is opened an exception is raised, the connection is not closed back to SQL Server. Eventually it's closed. But if I could do 1,000 of these connections, I may have 1,000 zombie connections back to SQL Server. And the fix there is to have a finally clause which always closes the connection down on success or on failure. So why string concatenation is wrong? I want to assume you kind of know this stuff, but I'll go through it real quick. You've got a shipping ID, type in a good guy types in 1001, it builds up a SQL statement. Select has shipped from detail where ID equals 1001. It says, yeah, it's shipped. No, it hasn't. Bad guys don't do that. They type in 1001, single quote, or 1 equals 1 dash dash, which changes the SQL statement. So 1 equals 1 is true for every row in the table, and now you've got the shipping ID for everyone's shipping item. You may think, well, who cares? When we presented this to Bill, he immediately jumped on this and said, oh, select credit card information from customer where credit card number equals whatever or 1 equals 1. Now you've got everyone's credit card information. And the dash dash operator, just a comment operator, makes it really easy to build a valid SQL statement. Then, of course, you can concatenate SQL statements. So you can actually select some data and then go and delete the orders table. I actually know of a website, and it was actually running a Perl-based commerce app that was homegrown. And they actually had a SQL injection attack, and they were selling cars. You could actually go in, and let's assume they were selling Ferraris. You could go in, you could actually change the price of a Ferrari to $100, log off, come back in again, buy it for $100. The only downside is you have to pay the full shipping cost. Come back in again, change the price back to what it was, because no one ever looks at the audit logs anyway, and you got yourself a Ferrari for like, $11,000 or something, because the shipping costs were fairly expensive. I can live with that. So SQL injection attacks are pretty serious. And the last one, and by no means least, is you can call really serious stuff at the back end. So the first question you're probably asking yourself is, hold on a minute. Deleting tables and calling these extended store procedures, not everyone can do that. So why can an attacker call those? Because you're connecting as SA from this web code back to the database. So which principle does that defeat? The principle of least privilege. You don't need to be SA to query a stinking database. You need to be SA if you're doing funky stuff to the database or attacking it. I'll grant you that. But just to query a bunch of tables? No. Like I have a database that I have at work that keeps track of a whole bunch of vulnerability statistics. I have an ASP.NET application in front of it, and it connects back to SQL Server as one specific account. That data is held in the registry. It's not held within the web space. That account can query 3 tables and execute 20 stored procedures. Nothing else. You know what? If you want the password for it, I'll give you the password, because there's nothing else you can do. And so any connection that's done through this web service can only query 3 tables and call 20 stored procedures. Nothing else. The only reason people connect from a web server or any code back to SQL Server or any database as a sysadmin account is because they're so damn lazy they don't want to handle the access denied cases. The problem is, if your code is not handling the access denied cases, then chances are very good that the malicious code will never get an access denied error either. So the next one is, how does the attacker know to type 1001 single quote, blah, blah, blah? Because if you type in something that builds up an invalid SQL statement, the exception handling code says, this SQL statement's wrong. So, I need to move the single quote from there to there. It's like hacking by numbers. And in fact, it's quite funny, when I actually presented this to the SQL Server team, they actually don't like me. Is James here?
He left.
He left. Oh, great. Okay, cool. So James left. That's great. I can tell you the story. James is one of the architects on SQL Server. He doesn't like me telling this story. So when I presented this to SQL Server, and there was actually a typo in this. I actually left out the word exec before XP_command shell. And you can imagine, in front of a few hundred people, they took great delight in telling me that I sucked because the exploit didn't work because I left out the exec. So I actually had the exploit code on my machine, so I tested it out without the exec. And the error message that came back literally was, ha, 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 you suck, you missed out the exec. So, like I said, it's hacking by numbers, It's like, just let the database tell you what to do next. So anyway, the points are, even if you don't build web apps, even if you don't build SQL Server apps or database apps in general, The ultimate lesson here has got nothing to do whatsoever with understanding how SQL injection attacks work. It's got nothing to do with understanding all this stuff. The ultimate lesson here is just don't trust user data. Just don't. If someone can give you stuff, bad guys will give you bad stuff. And the moment you think it's always well-formed is the day you're going to get whacked. And unfortunately, at that point, it's too late. And so here's an example. I mean, validate for correctness and reject it if it's not correct. As an example, if you take a social security number, well, the first question is why. But let's assume you do, and let's assume you do it for valid reasons. There is one valid representation for a social security number. 3 digits, a dash, 2 digits, a dash, 4 digits. Nothing else. If you've got a field or some data that expects that, you look for that, and if you don't see it, you reject the request because there is no other valid representation for a social security number. Don't go looking for bad things. It assumes you know all the bad things, and you don't. No one does. No one is that clever. When he's transmitting web data out, not only should he validate it on the way and make sure it's correct, when it comes to echo it back out, you should seriously consider HTML encoding or URL encoding the output, depending on how the output's being used, because that will actually neuter the JavaScript or HTML that's in the cross-site scripting attack. However, there are some attacks that do not require you to have the tag symbols. There's actually a number of attacks that do not require you have the tag symbols in place. So do not think you can take just any old junk and just HTML encode the output, because there's some attacks that do not require the tags. Examples are if you've got a tag where there's something that goes inside the tag, like some parameter in the tag, and some data comes from the user and then goes inside that tag, you don't need the tag symbols. In fact, if you do, you've got a problem. And so even HTML or URL encoding the output is not going to help you. And by the way, something else to be aware of, a lot of people say, well, when I take a request for SQL Server, why don't I just double up all the quotes? Well, I can actually send you a hex string that has no quotes in it, but every hex byte represents the byte, the character, but as a hex string. No quotes in that. It's another example of canonicalization where there's a valid representation of something else. If you're using SQL statements, then use SQL placeholders as well, parameterized queries as they're sometimes called. And finally, compile with a GS flag. And as David said, if you have crap code and you compile with GS, it's still crap. It's just taking a really nasty situation and may just make it nasty. It's just, we look at it as an insurance policy. You use good APIs, you review the code, you test the crap out of the code, and you compile with GS, just in case you missed something. And that's what we've done in Windows Server 2003. Just about all of the OS is compiled with that option by default, just in case. All right, I'm going to scream through this because we're basically done. And that is this notion of data mutation testing. Big problem right now is that most testers are goody two-shoes testers. They just want to prove that something works. As security testers, we don't want to prove that something works. We want to prove that something works in interesting ways, if you know what I mean. So the first notion here is you decompose the app. That originally comes from the threat model. Then you look at the interfaces into the app. This is how attackers think, ultimately. And so if you test the same way, you're going to find issues. Then look at the input points. Look at the data structures that are being used. And then document the valid data structures. Once you've done that, start mutating the data. And this is like a taxonomy of ways of mutating the data. So an example, let's say you got an app that consumes a file. So that's a container. A container has a name, the file name. So jump over its contents. Make the file name, make it long. Or change its length, jump over to length. Make it too long, make it too short. Make it 0 length. Make it random, make it null, make it 0. Back to the container again. Make it a link to something else. Make it exist when it shouldn't exist. Make it not exist when it should exist. Deny access to the file. All these kinds of things. So it's a way of structurally thinking about how to build data that sort of lies and cheats. An example, real simple example of a portion of an XML file and some of the things you can sort of lie and cheat about. The only reason I made it an XML file is apparently all Microsoft presentations have to have XML. So this has got an XML file on it. But let's just give you an idea of the sort of things you can look at and break it down to data structures, and how can you lie and cheat about those particular data structures. So from a testing perspective, and I flew through that because we're out of time, in most organizations, there's always someone who's just downright evil, and you should foster that person and make them a damn good security tester. The old type of tester just doesn't cut it for security testing. Reading the spec and proving that the stuff on the spec represents what is in that code. That's not what a security tester wants to do. They want to see if they can find other interesting bits of functionality. And with that, we have basically done the summary, just a repeat of the agenda. And the stock price sucks. Me and Dave have got to pay for the beer. And so that's why the little commercial for writing secure code in the second edition. And with that, we are done. Any questions? Yeah. Yeah, so first of all, I want to apologize. I ended up making some changes to the slides that are not in the handouts. So yeah, we'll give these to the Black Hat people who can make them available on the website, yeah. But I apologize for the changes that were made, but they were appropriate changes. Anything else? All right, oh yeah. That's a good question. The question is how hard was it to get people to change the mindset? Dave has, and I use this quote all the time, and I think he's dead right, and that is that people want to do the right, I think in general, people want to do the right thing. But sometimes you've got to show them what the right thing is. The good thing is a whole bunch of people at Microsoft, the security education that we put in place to foster this stuff was just a no-brainer. And the reason is, if you think about it, Windows and Microsoft in general, they're full of geeks. They love learning new things. And when you give them this time in the security pushes that we had to spend no time but spend time on nothing but security, they just soaked it in. And it was actually a bit of a no. In fact, the thing that worried us is the pendulum swung so far. It's like, hold on a minute, temper that with, we have to ship a product one day. Let's just temper that with a bit of reality. So if anything, it actually went to the extreme. But in general, I had no problems at all with people understanding what the right thing is, because all of a sudden they recognized, they were told what the right thing is, and they recognized the right thing to do, and they just do it.
It was actually pretty cool because, once we started teaching people what a security screw-up looked like, now you've got tons and tons of geeks with a new thing to check out. Wow, what is this? Okay, well, and then there was a huge synergy that developed. I mean, they started working on it together. And it's one of the reasons why the second edition is twice as fat as the first edition, because we got tons and tons of feedback and, oh, did you think of this? And, well, no, I hadn't really thought of that. Well, wow, that's interesting. And it really kind of went from there. So it's been a fascinating thing to be part of. And and let's face it, in today's world, security really is a feature. If you can say, well, my stuff's secure, it's going to stay up no matter what's thrown at it, and it's not going to turn around and bite you. That's a really nice feature to have, because people do buy security. I mean, if you think about it, how many of you replaced a car just because it's an old car and it doesn't have ABS, and you want a new car that does have ABS because you want your family to be safer? Same thing with code, I think. So it's been a really interesting experience.
The other thing that we never expected was it's amazing what happens when you take a bunch of people who are not security experts. But you got to realize that Windows and all these product groups are full of people who are experts in their domain. They understand file systems. They understand internationalization issues, and they know that stuff backwards. Then when you infuse them with a bit of security expertise, because they had to, because it was all part of the security push, we trained 8,500 people in 10 days to make sure they understood what the issues were. And it was mandatory for everyone to attend. And then there's a lot of ongoing training, and people started thinking about this stuff. They thought about their domain with this evil mindset, and the fact that stuff can't be trusted, and the fact that there are threats to the system, and the fact that if you build it, attackers will come. Well, they also started writing things about, well, man, my stuff, whatever it is, when it's exposed to these security issues, can have these kinds of problems. And in fact, one of the chapters in the second edition of the book is the internationalization issues of security. That came from the internationalization guys, not from us. because they wrote this document which is like, have you thought about all these issues when you all of a sudden start taking, you got a buffer that's this big, the most simple of the lot. You got a buffer this big, and it fits an English string, and then you convert that to German. The buffer's not big enough all of a sudden. That's just the most simple of the examples. There's all sorts of things they started thinking about that we never even thought about because we're not domain experts in internationalization. But it was amazing what was generated when all these domain experts started thinking about security. It's just amazing. Then what happens is they think about things, we spread the information around everyone, and that gets some other evil bastard thinking about something, and all of a sudden you got all these issues that people never even thought about, and that just cascaded. I mean, it was just unbelievable to watch. The energy was unbelievable. And if you want a metric, people really like metrics. It used to take me 5 minutes to walk to the cafeteria and back. Now, at the height of the security push, it would take me an hour because everyone would stop you to ask questions. Now it takes me only about 45 minutes. The cafeteria is literally 5 minutes away. But everyone's stopping to ask questions and bounce ideas around and such. The other thing that I've noticed is that the emails we get are no longer stupid questions like, what's a buffer overrun? It's like, I have this, I have these threats, I have these conditions, I have these restrictions that I need to be aware of, application compatibility, internationalization, robustness, shipping on time, all these other things that go into it. It's like, what do you think? As opposed to, what's a buffer overrun? It's like, these are they're very, very pointed questions now from people that really understand what it takes to build secure software, which is hugely exciting to see.
One of the coolest things was during the security audit, I was one of the 4 SAPs that got assigned to actually read code and try and find bugs, which turned out to be quite difficult. So it was, go beat your head against the wall for 2 weeks kind of assignment. And so I'd, go find my favorite pet peeves, like not setting, SO exclusive adder, et cetera. And so I go and I find all the places in the code that call bind, the whole Windows tree, it's pretty big. And I'm going through, and time after time after time, it's like, yep, got to do this to do it right, book says so. And, seeing comments in the code based on, something that I wrote in a book that actually fixed security problems on a widespread basis was very, very cool because it meant that we got to substantially improve the quality of what we ship, and that helps all the customers, and that's really the bottom line. So it's been it's been an interesting experience. It's also a little scary when your book becomes required reading for the whole Windows division. Try and tell 5,000 developers anything, and it's amazing. It wasn't as bad as we thought, though. It was, we didn't get that many people telling us that we, didn't know certain things from a hole in the ground.
It's true.
So.
Any other questions? Thank you very much for your time.